Today, let's talk about the different types of graphs and what they look like. Let's start with the most basic type that you can get, the uniform graph. So the uniform graph, if I were to draw it in a histogram graph, right, if this is a histogram, a uniform would just be just a straight line across the board. It's all uniform. This is what the histogram would look like. If I were to draw that graph as like a graph, let's say a scatter plot. A scatter plot, the key to a uniform graph in terms of a scatter plot graph is that the dots, because the scatter plot relies on the dots per se, that the dots of each plot are kind of uniformly spaced out. Next, if I were to say draw a line graph, right, where you connect that with a dotted line, it would first form kind of like a straight line and be uniformly angled. So it'd have like kind of like y equals x slope, slope of 1 in a straight line. Finally, a box and whisk box plot or box whiskers plot. And the key to a uniform box whiskers plot is that all the quartiles must be the same spacing apart. So they have to kind of all be spaced about the same distance apart. And that's how you know this box and whiskers has to be uniform, because this and this and this and this are all kind of the same spacing. Next, let's talk about a normal graph. So if I were to think of a normal graph, let's call this normal. A normal graph is a unimodal, and it's symmetric, and it kind of looks like a bell curve like this, right? And if I were to draw a normal graph as a histogram graph, it has a peak, right? Has a peak, and then as it goes down, there's these other peaks here, and it's kind of symmetric in this way, like so. So this would be considered our normal histogram graph. Um, if I were to draw the normal histogram graph as a scatter plot, the key to the scatter plot, notice here that there are more points in the middle. So the key to that normal is, well, you'd have some on the ends, but in the middle, there would just be so many points in the middle compared to the ends. The middle, there would just be so many. That would be our normal scatter plot. If I were to then draw this as, let's say, a line plot would then seems counterintuitive, but we have to think of the line plot in terms of slopes. So since there are a lot in the middle, the slope is going to be higher in the middle. So it's the slope is slower, but then as you get to the middle, it peaks up in the middle, and then it kind of trickles off a little bit, and it goes slower and slower. So that is what our normal line slope would look like. And then our box and whiskers equivalent for our normal. Remember, our normal has most of the numbers in the middle. So in the middle, it would be shorter. Our middle would be shorter, and then our whiskers, our lines in the outside, would actually be longer compared to the middle. So this would be a normal because I know that the outside here is longer than the inside boxes. Next, let's talk about our skews. Okay, so let's talk plainly about our skew. What if we do a skew right? So a skew right. A skew right graph, if you recall, the tail is pointing to the right. So it kind of looks like this, and the tail points. So the tail determines the skew because wherever it is pointing, that's the skew. If I were to have this as a histogram graph, of course, it would the mean and median would be higher over here, and there'd be probably be numbers like this, and then it kind of tapers off like that. This would be a skew right histogram. Well, what about our uh, scatter plot, right? Our scatter plot indicates there needs to be a lot of numbers on the right. So we go here, we have some numbers, but then we have a lot. Like over here towards the right, and then as the other parts, the numbers taper off more. So it's just saying here there's just way more numbers on the left at the beginning compared to the other parts. Next, if we were to analyze this in terms of a line graph, our line graph, remembers, is based upon slope. So at the very beginning, if it is skewed right, the slope at the very beginning should be high, pretty steep, and then it kind of tapers off, and maybe even evens out a little bit. And that would be our line graph there for our slope. For our skewed right. Next, think about our box and whiskers. Okay, so box and whiskers here, what that means our most of our information is going to be leaning towards the left, right? Leaning towards the left, and then there should be a longer line towards the right. This would be our skewed right. But box and whisker plots can also be labeled vertically. So this is one way. Another way would be to draw that exact same one would be upside down like this. The smaller part facing down, and then the top part facing up. Also with box and whiskers, you might see some dots following the skews. If you see some dots, those are outliers. So the little dots here are outliers. Those are just numbers that are so far away from the quartiles, they are considered outliers. Finally, we have our skew left. Right, skew left. And our skew left, as we recall it, our skew left means both of them are, the tail is pointing towards the left. That is our skew left plot. If we were to have this in terms of like a scatter plot, there should be not that many amounts of numbers at the beginning, but here closer to the end, there should just be so many numbers here, all grouped towards the right side of our scatter plot per se. And then if we were to draw this in terms of a histogram, if a histogram, our histogram, of course, most of the information is going to be towards the right. and then it bottoms out towards the left. Next, if we were to do a line graph, remember that we are talking about slope, so the slope should be pretty low as we work up to it. But then as we get closer, it should be high and maybe even off to the end like so. So this would be our a potential skewed left line. And finally, our box and whiskers equivalent. We want most of our boxes over here towards the right. Remember, the skewed left is counterintuitive to what we think, but the 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 tail is what points to it. If we were to then put this vertically, it would look like this, just like that. So that is how each and every single different type of graphs should look like, representative in different terms of scatter plots, lines, histograms, and box and whiskers. And that is all.